GDC techniques for paper 2. So this video is all about how to use your calculator to help you in paper 2. So let's get into it. Functions and calculus, that's what we're going to start off with first. So let's say I give you two functions like this, we have to find some things. So first, let's graph it. So I got to type it in, 2x squared. So I went ahead and typed them all in. Right, so here's f of x, here's g of x. We're going to specifically talk about how to use all the values under second trace, which is calculate, the calculate menu. So first I'm going to graph so I can see my graphs. Now look, if you notice my window's off because I was doing some trig earlier. So let me stop that. And the easy way to fix your window, you go to zoom and you put 6 standard. So that'll get you back to normal. Now there's been many times on IB tests where they're going to give you a window to look at. So you always want to fix your window to what they tell you. But for now, let's look at the standard one. And let's go to our second trace menu. So our calculate menu. Let's talk about every one. So value, what value does is it gives you a function, gives you the y value at some spot. So look, you click it. Let me do it again. Hit value. It says, hey, what x value do you want? So we'll say, like, I want to see what my y value is at -5. So -5 is going to give me the y value. And it says right here it's 123. That is doing it for the top equation, not the bottom equation. See, if I hit down, it's going to do, there's a bottom equation. Hit up, other equation. Right, so if I put second calculate value again, and I could put something like, I don't know, 3. It gives me this equation, and I can press up, and it'll give me the other equation. So 0. Now 0 calculates the 0 values. So if you hit second calculate and go to 0, right, so it gets the 0 values. Now this gives you a little bounce. Like if I want to find the 0 value right here, I got to go a little left, and I literally just mean press left on your calculator a couple times. Then it wants the right bounce, so you go to the 0, and hit right a couple times. Hit enter for guess, and you get your 0 value. About 1.1512. I can do the same thing for the other side. Right, go all the way around. Again, get to about where it is. It says left bound, go to a little left, and then right bound, go a little right of it. Now you have your 0 value. So that's what 0 does. Min max. So let's say right here I want to find my min value. So you hit second calculator. Now this happens a lot, especially with like, you gotta watch it if you're in paper 2. They say find the min or max. We think, oh, take the derivative so you go to 0, which is what I want you to think. But on paper 2, use your calculator. And I don't even mean like take the derivative set equals 0 and then use your calculator. I mean like literally just graph on your calculator. If I want to find the min max of this, if it's paper 1, I'll take the derivative set equals 0. If it's paper 2, I'm just going to graph that thing. Then find, in this case, the min. So we're going to find our min. Then we put the thing down there, whatever that is. So min works a lot like 0. Right, here's my 0. Here's my min. So we can go a little left of it and a little right of it. Then it says guess, you hit yes, I'll waste my time, and then you get your min, which is, that's 3, guys. If you see that, that's just 3. So 3 and -5 would be my min here. Which is also my vertex, by the way, which is also like vertex notation now. Blah, 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 blah. Now, one of the most important features, intersect. Right here, right? They want you to intersect two things. And we're going to use this a lot. Anytime you want to find a solution to stuff, you want to find the intersection, right? In paper 2, you got to use a calculator. So just go y1 equals y2 and find the intersection. Right, so again, if you're paper 2, you got to use the calculator, use it all the way. So in this case, I want to find intersection. I go second calculator intersects, number 5. And you just get kind of close to where they intersect. And by the way, you can move with both of them. So like you press up and down. Now I'm on this line. This one's a little easier to move. Press enter a couple times. And you get your intersection. So that's one answer. I can do the same thing for the other one. Again, ooh, that's taking too long. Let me press up so I can move on this one. Now I can move on this one. A lot more efficient. There you go. Now I can do the same thing here, right? If I want to solve this, I'm just going to graph it. I'll tell you sometime we won't actually do it, but you just put y1, y2, graph it, and then you figure out where they cross. Again, you have a calculator. Paper 2, use it. Use it to find the min and max they ask you, and use it to find intersection. Now let's go talk about some other ones. They want to find dy dx. Remember, that means a derivative. So I could do this two ways. I'm going to show you both ways. So first you can do it in your graph. So second calculator, dy dx, that means a derivative. and they want the derivative at 2. So all you do is type in 2. Hit enter. And that's the derivative of this one at 2, which is -4. And that said f, which is the one we were looking for. F is the parabola. If I want the derivative of the other one, I just press up, and it gives me that one. The derivative of that one is 3. So that's how you can do derivative using the graph. You hit second calculator, go to the derivative, type in the value they want the derivative at, and it'll give it to you. If you have 2 graphs, just press up and down, you can switch which one. Now you could also do it outside of that mode. You could go here to go to math, go down to end derivative. You're like, oh, I gotta so let me put a variable, so x. And then you're like, I gotta retype all that? Actually, you don't. The trick I learned is if you press alpha F4, it lets you type in y1 or y2, which is the equation we put in. So y1 was our parabola. Then we want it at 2. I should get -4. Same answer. Right, so that's a little trick to not having to retype if you want to do like derivative or integration. You press alpha y4 and you get your value back. Same if I want integration, right? If I want to integrate this, honestly, easiest way to do integration is using the math button. I like it much more on the math button than I do on the graphing one. It's too common with the graphing one. So we're gonna do the exact same thing. Go to math, go to end derivative, f integral. I'll put my limits in 1 to 5, and then here we're gonna type. I don't need to type that all in because I have it under f1, y1. So second calculator, alpha calculator, go y1, and then then again with integration we put the variable back. So you get that, and you get your answer, -9.3. Now remember what integration means. It's the area. So we just found the area from -1 to 5 on this graph here. Now that's not the only good thing that's with alpha. You can actually do lots of good things with alpha. So first, what I like to use all the time is one that lets you put stuff written as a fraction. So like right here, 3x minus 2. A lot of people make a mistake. They'll just write this on their calculator. 3x minus 2 divided by x plus 1. And that is wrong because the calculator sees this together. So the calculator would do 3x then minus -2 divided by x. So let's put the calculator puts these two together. So if you want to fix it, you put parentheses. If you want to make it even easier, put alpha y equals. The very first one lets you put a fraction bar. So now you just go, oh, 3x minus 2. Oops, wrong minus. And on the bottom you can type in x plus 1. So this is the best way to do it. If you want to put something as a fraction, next one is summation. Now we should know how to do this even without a calculator. So that at least the general idea, right? You plug in 1, then we plug in 2. We keep on plugging in until we get to the top number. Skip a couple of these, and then let's say we get to 20. Again, they could do some paper 1 with the number a lot less than 20. So what you do is keep on plugging in, and then that e means sum. So you add them up. Again, with 20 it would take forever. But there's a couple of tricks. You could figure out that this is an arithmetic sequence, and then you can just do an arithmetic sequence summation. Or if you could use a calculator, even easier, all you have to go is math. Look for summation right there, and then you just type it in the way you see it once it pops up. Okay, let me do that again. So you type it in the way you see it. You can do any variable you want. X is 1, 1. Type in the equation, 2x, or I guess type in the max where you're stopping, and then 2x minus 3. Hit enter, and you get your answer, 360. If you add up all these, you're going to get 360. Next up is log base. Now that lets you do bases that are not 10 or e. Now remember, log with the base e, let's say log base ex, is this the natural log? It's the natural log of x. Log with the base 10 is the one we use all the time, so we just put log x. That's a basic log. So log base 2.7, the way we do that, well, we should know change of base format, so we just write in log 7 over log 2, right? The base goes in the basement, 7 goes on top. You can do it in your calculator using math, and go to the bottom where it says log base, and it lets you type it in the way you see it. So either way it's easy. You get your answer. End derivative, we talked about how to do that, right? Just go to math, end derivative. Put in your variable, and the next thing we do is we go here. Now you don't have to retype your function if you already have typed in. If you don't, just type it in. Otherwise, you go alpha F4 and then type in whatever variable we want to type in. In this case, y1 is our F1 function, and put what value you want it at. If you want to do definite integer, we talked about this already. Now this is x plus 1. Do we have x plus 1? Yes, we did with g of x. I mean, it's not that hard to type it in again. I just wanted to see. Right, same thing here. You go math, you go integration, 0 to 3 in this case. And that means we're finding the area from 0 to 3 underneath the curve. And you can type in x plus 1, it takes 2 seconds, or you can press alpha of this. But honestly, with x plus 1, I'll just type it in. It's so quick. It's wasted time. That's all I'm doing. So inefficient. Anyway, type it in, hit enter, and you get 7.5. Now, here's something that IB added new to the past couple years, and that's total distance traveled. So this goes with our kinematics, right? SVA. If you want to find the total distance traveled of something, it's this integration. It's this formula right here. It is in your formula sheet. It's right there. It'll say total distance traveled. It'll say this. Keep in mind that this is the velocity function, right? So you can't find the total distance traveled if you have the displacement function. It has to be the velocity function this works with. I mean, you could do it with displacement, but it's more work. It's actually a lot easier with the velocity function. So let's do an example real quick. Particle moves in a straight line with velocity function. This that was supposed to be highlight, not and you cross out. Way to go. And so following without, well, we're gonna do it with the calculator. Following using the calculator. How far does P travel in the first 4 seconds of motion? So again, how far it's like total. That's asking us total distance traveled. How much has it moved? Total distance. So we're gonna go math. F integral. Math. F integral. It'll work the second time. The first 4 seconds of motion, so we're going from 0 to 4. I'm gonna type my equation, but I gotta do this absolute. Remember, with this thing, I gotta do the absolute value. And by the way, what work will you show? You show the setup: 0 to 4, absolute value of t squared minus 3t plus 2. If you really want, you can just type in v of t, but it helps if you show the equation. Right. So how do I get the absolute value? Well, a couple ways. You go math over a number. Very first one is absolute value. Or if you go, let's go there. Alpha. I think the second one has absolute value right there. It also has the e if you want it, and derivative and integration, and the base. Hey, it's all right there. So do that. Then you just type in your equation. Again, we don't have a t, so we're going to use x. And then we want it. Then we put our variable x. You hit enter. And that's the total distance traveled in the first 4 seconds. It's traveled 5.6 meters or whatever, meters per second. So find the displacement. Now this one's different. Displacement just means how far have you moved. Like if you started here, so that's where you started there, right? We went up 3, and then we went right 2 to 3. Displacement is this part. How far are you? That's displacement. While total distance traveled is 3 plus 2. So that's what displacement. All we do is it's a straight out integration. Just integrate the velocity function from 0 to 4. No absolute values. So you can get my equation back. Right here is what I wanted to get back. Now, the sad part about this, there's no way to just get rid of the absolute value. I could try to do like just delete. Oh, but it did work. Hey, how about that? So look at, good thing is you could get rid of the absolute value, no problem at all. Then hit enter and you get your answer, about 5.3. See, now it's a little less because at some point it went negative. That's why this is a little less. So that graph probably went like positive, 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 and then negative. That didn't work. So it's a lot harder to use 2 different screens than it looks. Anyway, next up, let's go to some statistics. So you want to use your calculator to quickly find mean, median, and standard deviation and quartiles. Very simple. Easiest way to do this, like let's say we give this raw data right here, right? You go stat, edit, type in your value. So 5, 7, 8, 10. 10 starts with a 1, not 0, and 3. So you get my values there. Now if I want to find all that mean, median, mode stuff, you quit. You go to stat. You go to one variable stats. L1. Now notice I don't have a frequency list here, so make sure that thing's blank. Sometimes you do have a frequency list, and you can put L2 there, but right now I don't have it. Hit calculate, and I cannot stress that enough. By the way, when I go back there, because it is super important. I have seen so many people get something wrong because they left that. A lot of times your calculator leaves L2 there. Don't do that. So then here, my mean is 6.6. This is the summation. I really don't care about that one. This is the summation squared. Who cares about that either? This is standard deviation. These two, we use the bottom one for standard deviation. This is like a population. This is a sample. We use the bottom one. Scroll down. Min, max, median, Q1, Q3. If I want IQR, IQR is Q3 minus Q1. And again, if they ask you that, that's always going to be a point. Just write down the formula. Okay, I know what IQR means. Q3 minus Q1. In this case, 9 minus 4, so 5. Don't forget, leave frequency list blank if you don't have a frequency list. Cannot stress that enough. So that's that one. Let's go down here. So look at this one. This one you do have a frequency list. Hey, there's a frequency list. Let's make this a little tougher actually. I'm going to change these values around. Let's make this one 0 to 2, 3 to 5, and 6 to, let's go 9, make it not as easy. Right, so in this case, now remember, if you have a table here, when you go L1, stat, edit L1, I got to clear this data here. So if you just want to get rid of one, you put delete. But if you want to clear the whole thing, do not put delete, put clear. Now I got to type in these values. You know, I cannot put a range. So when we do that, we put the midpoint. So in this case, we're going to put the midpoint here. So between 0 and 2, just add up, divide by 2, which is 1. That's 4. 6 and 9 is not going to be as nice. That's why I did it. So 6 plus 9 divided by 2 is 15 divided by 2, which is 7.5. So put 7.5 for that one. So back here, I need 1, 4, 7.5. Now I actually have a frequency list, so 12, 39, and 6. And I can do the exact same thing I did last time. I go stat, calculator, one variable stats, so we only ever use one variable stats. List is L1. I have a frequency list this time, so L2. The way you get that is you put second and number 2. So you get L2 right there. Hit calculate. And you get all the same stuff. I got the mean, I got the standard deviation right here. We use the bottom one. Right, I have my min, my max, my mean, my median, my Q3. Hey, right here, IQRB0. Fun fact. So that's that one. Now let's talk about normal distribution. Right, so again, key thing about normal distribution, they have to tell you it's normal. Only time it's going to work, they tell you it's normal. So don't do this unless they say, hey, this is normal distribution. So remember, so the way we get that out is we go distribution, so second distribution right here. Now only two we're ever going to use are these two. Normal CDF and invert normal. Only two. We never use the PDF. Scratch that out. It's only these two. Now the easy one's the normal CDF one and the harder one's the invert normal one. So first thing apprentice first wants someone to know is z-scores. Remember, z-scores is a special case. We call that the standard normal. Right, so again, if they say z-scores or they say standard normal, that's a special case. It means your mean is 0 and your standard deviation is 1. So it's a special case. So look at this first one. Right, they want me to find the probability, it's a z-scores. So if I see z-scores or standard normal, I got to be thinking this. So z-scores or standard normal, you think, oh, that's my mean massive standard deviation. So they want me to do between negative 4.5 and 1.03. So I go my second distribution. I go normal CDF. I'm trying to find between two things. And I type in my values. Negative 0.45 and 1.03. Now again, standard normal or z-score is 0, 1. That's usually the default when you turn on your calculator. It's usually on 0, 1. So you hit enter and you get your value. It's about 18%, 18.6%. Now look at this one. They want me to do less than negative 1.03. So in that case, again, we're still doing the z-score. So that means this is 0. I want less than negative 0.34. So that's 0. Negative 0.34 is over here. I want this side. So the way we put that in is normal CDF. Lower bound is negative E99. Upper bound is negative 0.34. So negative E99 to negative 0.34, 0, and 1. Because again, we're doing a normal curve in this case. So second distribution, normal CDF, negative E. Now remember, we do a chemistry right here, 99, not the exponential. And then right here, we put negative 0.34, 0, 1, because we're doing a standard normal, and you hit enter and you get your value. I'll do the same thing here. This one says greater than. I won't go through the motions, but the same idea. Right, so you want greater than 0.56. So it's a bad graph. So we're doing normal one, so that's 0. Negative 0.56 is to the left. And I want greater than, so all of this. So it's going to be from there to E99. Again, that's if they don't give you the mean standard deviation. They're just telling you, hey, like it's a standard normal or a z-score. That means you do that. I could do the same thing when I'm going to go backwards, right? So in this case, if they give you a percentage, then they want you to do invert normal. The key thing though is that to be on the left hand side, right? So if I give you like this, and I say, oh, this percentage here is 0.3, then we're good. But if I give you this, and I say, hey, this percentage is 0.6, you gotta use the opposite side. It has to be left side. You gotta go here and go, oh, that's 0.4. So that's the key. Suppose you want to find the z-scores with an area of 0.43 to its left. Stupid z-scores. So that's standard normal. That means your mean is 0 and your standard deviation is 1. So keep that in mind if you ever see z-scores standard normal. Right, and so the area of 0.43 is to the left. So keep in mind I'm starting from the left hand side. So if it says shorter or smaller or less than, then you start on the left hand side. So 0.43, now remember halfway is 50%, so we're like around here. And if I want to find what value that is, we're going to go to our calculator, second distribution. Invert normal, we'll put, that's our area, 0.43. Then our thing is 0, 1 because we're doing standard normal because for some reason we lost standard normal. And you get your answer. That right there is -17. Right, it's a little less than 0, which it should be. I can same thing going the opposite way. Right, this area is to its right, so it's saying, hey, 0.62, nothing, you're starting from the right hand side, like it's too heavy or too big or something like that, you have to start from the right hand side. 6.62, that's more than halfway. Halfway is 50%, so this is like over here actually. 60% more than halfway. And again, I cannot use invert normal that way, because if this is 0.62, I gotta find the other side. And the other side is going to be 1 minus that. So 0.38. So we're going to invert normal with that. Let's give me my value here. 38. Hit enter. And I get about -305, which again makes sense because this is 0, so we should be left, we should be negative. This is a real problem now. The length of songs of a Billboard's Top 100 chart for the past 10 years have a mean of 230 seconds. So our mean is 230. And a standard deviation of 23. 98% of the songs are shorter than some length. A. Calculate the value of A. So this is a classic IB problem. Classic. They'd love to ask questions like this. So let's draw it because it helped me. And it hopefully helps you. So this is 230. Again, I don't need to draw 23, whatever. 98% of the songs are shorter than some length. So shorter means you start on the left hand side. If it said longer, I'll start on the right hand side. If it says shorter, start on here. Now 98%, right? That's almost, this whole thing's 100%. So 90% is like over here somewhere. So like all of this is 0.98. Now the good news, that's the side I could use. I don't have to flip it over, right? When I start from the left, that's what I want. So I'm gonna go on my calculator and put invert normal. So my area is 0.98. My mean this time, I actually have a different mean. It's 230. 230. 230. And then 23 is my standard deviation. Hit paste, hit enter, and I got most songs are shorter than 277 seconds. So most songs are shorter than 277 seconds. So that's the idea. Now let's talk about this real quick. Another good example. An adult scallop population is known to be normally distributed with a standard deviation of 5.9. So that's my standard deviation. If 15% of the scallops weigh less than 5.3, ooh, so they're giving me a percentage and its weight is less than 5.3. So they're saying, hey, the odds that you're less than 5.8.2, what did I say 30 for so long, is 15%. Find the mean. Now this is a special case. Anytime you're missing a mean or standard deviation, there's a special formula you have to use in your formula sheet, which is normalization, which is this. That's how you normalize things. It's over, that's the wrong formula. It's x minus mu over there. Here we go. That's how you normalize things. If they have to say normalize something, you could do this formula also, which means just plugging your values. Mean, standard deviation, and x. In this case, I'm trying to look for the mean. So I don't have this. I do have this as 5.9. I have my x. This is my x right here, 58.2. So I think I gotta find is my z. And look, we did like 20 practice problems on how to find z right now, right? Z is always the invert normal with the standard deviation, with the 0 and 1. Standard and normal. So all we got to do is draw this picture. So if you're less than 58.2, it's 15%. So like 50% on this side. And then this is 58.2. So what we're going to do is we're going to do invert normal. That's on the right side, so I'll put 0.15. We use 0, 1 because I don't have my mean, so I can't use the mean that we know. So I got to use the standard normal mean. That's why we do this. That gets me my z. That's how you always find z. If you want to find z, you do this. So z is going to go whatever it equals. I don't want to put it in because I'm tired. Let's say negative 0.3. That's going to go here. And then you just cross multiply and solve. Right, so that's how you solve when anytime you're missing a mean or standard deviation, you got to use this formula here. So how do you set it up? Well, put the mean or standard deviation in. Your x is about x value they give you. And then you just got to set this up. So it says less than, so I start on the left hand side. Do invert normal. If it said greater than, I have to start on the right hand side. So I figure out the left side. And so on. Okay, almost done. Binomial probability distribution. So again, binomial is different. They don't tell you when it's binomial. You just gotta notice it. It'll say stuff like exactly, or at least, or at most. And there's always an end value, like, oh, we took a sample of 10 things, or something like that. Like, there's all this, like, keywords they use when it's binomial distribution. So let's do a couple examples real quick. Studies show that 63% of teenagers eat breakfast regularly. Suppose a random sample of 5 teenagers is taken, so we're ready. Like, oh, they're taking a sample of 5? I'm thinking binomial. What's probably that exactly for? Okay, now it's definitely binomial. Eat breakfast regularly. So, binomial distribution, if we go to our calculator, second distribution, is toward the bottom. So there's PDF and CDF. So now our binomial PDF is like position, it's exactly. Binomial CDF, or particular, probably better particular. CDF is cumulative, like you're adding up. So it has to be, that's when it's at most or at least. That's the one where it has to be like this. Right, so when it's exactly, when you have a particular solution, PDF, and when you want a cumulative solution, you want to add up all the values, CDF. So exactly for E. So it's PDF. So I need trials P and N, right? So trials is N, like how many do you have? P is your probability that's going to be successful. And then X is a value you want. In this case, we want exactly 4 teenagers. That sounds kind of weird. And then so our total is 5 teenagers. And our probability of them eating breakfast regularly is 0.63. So you have all that information. If I was going to write it out on the paper, I'd write binomial PDF to show my work. And I'd be like, oh, it's 5, it's 0.63, it's 4. So I'm going to type that in. So 5, right here, 5.63, and then 4. Hit paste, hit enter, and you get your answer. About 29%. Next one. Studies show that 60% teenagers eat breakfast regularly. So same study. Suppose that the random sample of 5 teenagers is taken. What's probably exactly 4 eat breakfast regularly? Hey, we did that already. 0.29. So this is 0.291. Now, with the trouble, it's if they ask what's probably that following number eat breakfast regularly, you do the exact same thing. You just plug in 0, 2, and 3. I don't want to go through all that work. But let's talk about this one. What is the probability that at most 3 teenagers eat breakfast regularly? So at most means, again, for me, I just think about it as food. If I want at most 3 cookies, that means 3 is my limit. So I want at most 3, 3 is where I stop. So there's 2 ways to do this, actually. So we could go probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3. Right? That's at most 3. So what's odd? Do you get 0, 1, 2, or 3? That's what at most means. So you can add up all these values. Well, I guess not 4. You got to have 0, 2. I got to figure out what 1 is. Man, so then it's not as I thought. But anyway, you can do that, or you can put in your calculator. So you have second distribution, binomial CDF. Right, so now CDF we're doing cumulative. This is the right way I want it. So I'm going to type in, it was 5 teenagers eating food, it was 0.63%, and I want 3. Hit enter, and you get your probability, about 61%. What's probably that at least 2 eat breakfast regularly? So at least 2 is a different thing. So at least 2 is x is, so right, if I want at least 2 cookies, that's x is greater than or equal to 2. Now it's pointing the wrong direction. So a couple things here, right? When it's pointing the wrong direction, the first thing you gotta do is flip it. So you do 1 minus binomial CDF. Now when you flip it, think about this as a closed circle going that way. The opposite of that is an open circle going this way. So we're going to be less than, with no line, we lose a line, and then 2. Still can't plug that in my calculator, I need a line underneath it, so 1 minus binomial CDF, x is less than or equal to 1. And that's what I put in my calculator. So don't forget the 1 minus. A lot of people forget the 1 minus. So you can do this in your calculator if you want first, but don't forget to do 1 minus. I just do it all at once because, don't want to make a mistake. So 1 minus second distribution, go down binomial CDF, blah, blah, 1, hit enter, and then you get your answer, about 93%. So there's that. A couple more things I decided in. Next up, regression lines. Now, it's something that this is one of the newer things they took in, right? They took out matrices, they added regression lines. So this has been on the test like every year since then. So first thing we do is type in our data. So we go stat, edit, L1, L2. Let's get these values out of here. So clear, type it in, and boom. Right, so now they want me to draw a scatter plot for this data. So that's something we don't do as often. So we go second stat plot. You can turn a plot on. And then we want a scatter plot, that's that one, so we're kind of all good. You hit graph, and you don't see anything. Well, let's think. Oh, I just have those graphs on. Let me turn those off real quick. Delete, don't need you anymore. Right, but now if I graph, I'm not going to see anything. Because that doesn't fall, like that's on within the window. So easy way to fix it is you go to zoom stat, which is number 9. Zoom stat number 9. That turns it on and does this. So now you can see your scatter plot. It looks like a positive correlation, a little linear, but just like some outliers right there. So we have that. Now they want me to calculate R. So the way you do that is we do like a linear regression. So we're gonna go. Well, actually, first before we even do that, when you calculate R, you have to make sure of one thing because not all of them have it, right? So on your calculator, especially it has to be a TI 84 or above. 83s don't do this. You gotta go to mode. You gotta go all the way down to stat diagnostics and turn it on. By default, it's on off. I have no idea why. I have issues with TI, that's one of the main ones. So like here, diagnostic, mine's is off, right? So I gotta turn it on. Now I could find my R. So quit, stat, calculator, we're gonna do linear regression. L1, L2, we do have L1 to L2. Now here's very important, guys. Frequency lists, this is not a frequency list, right? It's tickets and that's beverage sales. So we're going to clear that, make sure it's not there. So no frequency list, unless it specifically says, hey, this is the frequency of this thing happening, right? So like that. Store request, that's if you want to put it, if you want to make a line out of it, you do like alpha Y1 or whatever. So let's type it in for Y1, you don't need to do that, leave it blank. Anyway, hit calculate, and it calculates it for you. R is 0.77, right? That's moderately strong. So 0.77, R2 is right there, which is a different thing than R. And then A and B, right? B here is a y-intercept, A is a slope. So, by the way, the slope would be, right, Y over X, so it would be beverage sales per ticket sale. So, we get about 0.35 beverage sales per ticket sale. So, this is a moderately positive, I believe, linear correlation. So, that's the correlation between these two. Find equation least squares regression line. Hey, we just did that. Y equals 0.350 x minus 0.293. There we go. Now the music festival is extended by 1 day, and $35,000 worth of tickets are sold. Now keep in mind, $35. This isn't thousands, so 35,000. We're just gonna type in 35, right? Because this isn't thousands, so just 35. Predict the beverage sales for this day. So, well, we have an equation. We're gonna type it in. So y equals 3.350 times 35 minus 2.93. Now there's a couple ways you could do this. I haven't put it in my graph, right, when I did that line thing. So if I want, I could do our skills we learned earlier. We go second calculator, put value, and hit 35. And valid input because my window's not far enough. Hey, that was way to go, Frigo. So I can make it a little longer now. It's like this is pointless. But anyway, I could do that. It said invalid because my window didn't go far enough. So now I can hit 35, and I get 11.959. You can do that, or you can just type it in. You have the equation. Just do it by hand. So 0.350 times 35 minus 2.293. This is a good time for me to tell you, don't forget 3 sig figs. Right? IB, it only matters on paper 2. They want 3 sig figs. It's like right here, 11.957. I'll just round that to 12. Because 3 sig figs. I'll be this one, but I got to move it, and it kind of works out that way. So 12. So we got 12,000 beverage shows that day because it's in thousands. Come on, the reliability of prediction. So a couple things here, right? If it's in between your data, given data, I should say, it's called interpolation. In between intrapolation, I believe it's actually spelled. Intrapolation. That's usually a good estimate. Now it's not 100% because it all depends on the R. Like my R here is pretty moderate, so it's either way, it's not gonna be the greatest. But if it's given in between your data sets, so what does that mean? So here I got my lowest is about 15 or 12 actually, and my highest is 29. I see. So if I said estimate the sales of 30, no, sorry, in between those two, 12 and 29, it's like 25. If I said estimate the sales of 25, then it's an interpolation. It's probably gonna be a pretty good estimate. If it's outside the given data, like 35 here, then we call that extrapolation, and it's usually not good. Again, it's not always 100%. If it's really close to the values and had a strong R, like this one, if it had a strong R, I would say it would be a good estimate. But in this case, since our R is not strong and it's outside the data set, I'll say it's a bad estimate. So that's the idea. Now, if it's really far out, no matter what, I don't care how hard, I don't care if the R is 100%, like 99%. If it's like out there, like they're like, oh, how about 29? They want like 30,000, or 30 million, not gonna work. Okay, binomial expansion, right? So you know some of my favorite things to do. The expression can be expanded too. So this one you could multiply it all out if you want, if you're a loser, all the way, or you could do binomial expansion, which is start with the power 5/0. First term, second term. Keep on doing this until they match. 5/5. First term, second term. Don't forget the way the powers work, right? Whatever the bottom power is, matches the right one on the top. So 5 and 5. And then these two powers have to be that one. So 0 plus 5 equals 5. And 5 plus 0 equals 5. Now, this is usually on paper too, because you have to use like big numbers. How do you find 5 right here? Well, use your calculator. You put 5, you go to math, go all the way to probability, then NCR, this is NCR, 5. You get 1. So NCR. You do this for all of them, multiply it all out. Don't forget the 5 goes to both of these, so that's like 3 to the 5th. You can use a calculator for that too. But that's the general idea. Like that's the key thing about using a calculator is knowing how to do this, but the main idea is knowing how to expand this. So most of the time they'll actually ask you a question more like this. 3x minus 2 to the 6. Let's find a term with x to the 4th. So in that case, I go, okay, it's 6, it's 3x, it's negative 2. If I want x to the 4th, that means here's my x, I want this to be a 4. Well, if that's a 4, and these have to add up to be 6, then this has to be a 2. And if that's a 2, then this is a 2. I can find this in my calculator. C NCR2. So math 6. Wrong one. 6 math NCR2. So 15. This goes to both. So 3 to the 4th, x to the 4th. And then negative 2 squared is 4. I multiply all those numbers there. So like 15 times 3 to the 4th. I know the 15 is down there. Gotta deal with it. Times 4. And I get 4860. So this becomes 4860. That's a coefficient of x to the 4th. Now that's a coefficient. They say term, so I wrote the whole thing. If they say coefficient, they expect this. So there's that one. Okay, last thing we're going to do. Find the x-intercepts of the graph of f. So the way we're going to do this, a couple things I want you to keep in mind. So notice how right here is your domain. So I'm going to make my graph only care about that. If I want to find the x-intercepts, I'm going to only care about that part. Now, when I'm going to graph it though, make it look like this thing, right? But only graph this part. So I know it's a little tricky, I'll explain it right now. So first thing, let's type that in. So this 3x minus e to the x minus 2 minus 4. It's like that. Hey, graph. Oh no, I got my stat plot on there. And actually I want to show you something. Let me go back. Let me go stat edit. Let me clear these out. Right, now if I hit graph, look what happens. Invalid dimensions. People always come to me with this. Like, I don't know what's going on, my calculator's broken. Invalid dimensions. Well, that means because you have no dimensions in your stat plot. So that's what's going on there. Your thing's clear, and then you're still trying to graph a stat plot. So just turn it off. Actually, an easier way to turn it off is go here. See how it's highlighted, plot 1? Go up there, hit enter. Now it's not highlighted anymore. So now you can graph it. Now my window's off, so I'm going to stop it, pressing on, and go back to zoom standard, zoom 6. So I get sent that. But again, in reality, I don't even want that, right? I want 1 of 5. So let me fix my window. Let me make it match this thing right here. So my window, I'm going to go -3 to 6. Then my y is going to go, looks like -11 to 3 to 4. So I'm going to graph that. And actually, let me fix this. See how my domain's -1 of 5? They don't want me to go, they're trying to trick me here going all the way. I just want to go -1 of 5. That's my domain. I can't go any further than that. So my window's actually, let me readjust that. Let's go -1 to 5. You're not going to catch me, Ivy. So I'm going to do that. I know the window's all that, but look at the domain. -1 of 5. So I got to watch that. That's the only thing I'm going to graph. First, let's find the x-intercepts. Hope you know how to do that. Second, calculator, 0, right? And we go to low left. And then here's the other one. We go low right of it. Hit guess. And I get about 1.54. My 3 sig figs. Remember, we're in paper 2 now. 3 sig figs matters. 1.54. Now, they only take it on one problem. But you don't want to lose the points because you're being lazy. Now we're going to the other one. Again, the way this works, you go to your 0 and go low left. Left bound, hit left a couple times. Like literally hit left a couple times. Then go to your 0 and go right a couple times. That's the way it works. Hit enter. 4.13, right? Round it up 3 sig figs. 4.13. Now here they want me to graph it on sketch grid below. So I have this. So it looks like, so I already know my x-intercepts, so let's use that. About 1.54. Doesn't be perfect, but just has to be around there. 4.13. It doesn't be perfect, it has to be around there. I probably want to find my max so I match it a little bit. Like, you don't have a perfect graph, but you do want to have it, like, there's key points they mark down. Like, they want to make sure your x-intercepts are right. They want to make sure your max is around the right spot. So let me find my max real quick. So let's go left over max, because here's the max, let's go to the right of it. My max is at 3 and about 2.29. So around 3 and 2.29. So you don't have to be perfect, but around there. And then look, the way my graph goes, it looks the lowest it goes is like over there to about, now again, I don't want to go past 5, so it looks like it's fairly down there. Like, we're going all the way to -11. Let's go trace. Let's go. Oops, that didn't work. Hit trace, so I could trace my graph. That's a good thing about trace. It won't give you the zeros, but it lets you know. So down there, I should be about at -9. Now on the other side, here's a quick trick to go that way. Just hit like 0. Then it'll hit you at 0. So now we can go this way. And at -1, I'm at -7. So -1, I'm at like -7. It doesn't be perfect, but you want to be around there. And you probably actually want the y-intercept. Now again, don't need to be perfect, but easy way to figure it out. Just hit 0 on your graph. And it'll find the value for you. Oh, 0 is -4.13. So I have these points, and you just kind of connect them. Oh, this is going to be a joke. Something, oh, missed that one, to that effect. Again, not perfect, but something to that effect will get you full credit. Because when they grade these things, they're checking your x-intercepts, your max is sort about your max, your y-intercepts are sort about where your y-intercepts should be, and then you don't go past -1 and you don't go past 5, because that was a domain. Now, a lot of times they give you a graph, that's how they want you to fill it out. Last thing, and then we're done, find a gradient. Remember what gradient means? Derivative at x equals 2. So, a couple ways to do it. You can get out, but we have a calculator here. So, second calculator, go to derivative and just hit 2. So, derivative at 2 is 2. And there we go. Done. And that's the last video for IB Math. Don't cry. I will.